Hi, I am Fabio Cermelli, and I'm a second-year PhD student at the Visual and Multimodal Applied Learning Lab at Politecnico di Torino, supervised by Prof. Barbara Caputo. There's a lot of hype around autonomous cars, but have you ever wondered how a car can learn to drive by itself? And in particular, have you ever wondered how a car can see what's around it? My PhD thesis focuses on that topic, which is known as computer vision, the field that studies how a machine can see the world. Computer vision is a broad research field, but the most important problems that humans have been interested in solving are image classification, object detection, and image segmentation, in their increasing order of difficulty. In the plain old task of image classification, we are just getting interested of the labels of all the classes present in the image. In object detection, we come a step farther and try to predict the location at which objects are present. Image segmentation takes it to a new level, but try to find out accurately the exact boundary of the objects in the image. The most important vision task for autonomous driving is semantic segmentation. Since autonomous cars need to have a precise and dense information about their surroundings. For example, a car needs to understand if a person is going to cross the street or to detect the color of a semaphore. Well, you now might be wondering, that's beautiful, but how a car can do that? Behind the artificial vision systems, there is something that mimics the human brain, which is called deep neural network. These algorithms take inspiration from the way our brain works and learn by examples. In particular, by given a set of data, they update the inner parameters to fit them, slowly learning to perform the task. The current pipeline to obtain a working segmentation model is to first identify the categories you want to predict, and to collect images you need for training, and pay someone to annotate them. And when you get the annotated images, you can start feeding the network from the given examples, and then it will slowly learn from them. When training is over, the models are ready to go in the world and predict anything inside. Up to now, it looks pretty simple, isn't it? However, there are two major drawbacks of this pipeline. Collecting and annotating a dataset is extremely expensive. Annotating a simple semantic segmentation image requires nearly $3, and we need to make hundreds of them. The second is that the models are fixed after training, so they are not able to extend their knowledge over time in a cheap and flexible way. The goal of my PhD is to find a solution to overcome these problems. The first is known as weekly supervised learning. To decrease the cost of semantic segmentation models, we are performing research investigating cheaper type of annotation such as points, scribbles, bounding blocks, and image level labels. In my research, I am investigating how to use the cheapest type of annotation, image level labels, to get a segmentation model. In practice, image level labels do not provide any localization cue, and the model needs to discover where the object is and also what are the object boundaries. The second problem is known as incremental learning. The goal here is to take a model already trained on a set of categories and extend it to predict new categories in a cheap and efficient way. While on the surface it may appear simple, the hardest challenge of neural networks is that they are prone to forgetting, just like us. When we teach them something new, they slowly start to forget what they knew, encoding in a performance drop. To avoid forgetting, we should use techniques to force them to remember the past knowledge. Do you remember your middle school teacher that always said, review what you studied? We force the network to do something similar, making them learning new things without forgetting. In the last year, we published a paper at the Computer Vision and Pattern Recognition Conference, the top conference in the computer vision field, where we proposed a model able to learn new categories over time. If you're interested in what we do and know more about us, you can visit my Zoom meeting room during the PhD day, or you can write me an email. Thank you for your attention.